Stacy wants to find the derivative of f of x equals x squared plus 1 at the point x equals 2. Her table below shows the average rate of change of f over the intervals from x to 2 or from 2 to x. And these are closed intervals. For x values, they get increasingly closer to 2. So we're talking about the average rate of change of f over these closed intervals for x values that get increasingly closer to 2. It looks like we're going to be dealing with some type of a limit, or we're trying to calculate some type of a limit or approximate some type of a limit. So let's read this data here. So these are the x values, and she's trying to find the average rate of change between each of these x values and 2, or the average rate of change of the function between when x is one of these x values and 2. And then she has the average rate of change that she pre-calculated. So we don't have to get a calculator out or anything like that. And just as a reminder, how did she calculate this 3.9? Well, they tell us. She took f of 1.9. What is the function equal when x is 1.9? From that, she subtracted what is the value of the function when f is equal to 2. So that's really our change in f. And she divided it by the x, which is 1.9, minus 2. So change in f over change in x. So what is the average rate of change of our function over that interval? And so she did it between 1.9 and 2. She got 3.9. Then she gets closer to 2. So now she's doing it between 1.99 and 2, and it becomes 3.99. It looks like it's getting closer to 4. She gets even closer to 2, and the average rate of change gets even closer to 4. And then she goes on the other side of 2. You could view it as this is x approaching 2 from the left-hand side, and this is x approaching 2 from the right-hand side. So when it's 2.1, the average rate of change is 4.1. When it's 2.01, once again, we're getting closer to 2. The average rate of change is getting closer to 4. The closer we get to 2, the closer the average rate of change gets to 4. So what this data is really helping us approximate, it's really saying, okay, the average rate of change we know is f of x minus f of 2 over x minus 2. But what we're really thinking about is, well, what is the limit as x approaches 2 right over here? That's what this data is helping us to get at. And it looks like this limit is equal to 4. They give us the data here and says, look, the closer that x gets to 2 from either the left-hand side or the right-hand side, the closer that this expression right over here, which is this number, gets to 4. And you might recognize this is one of the definitions of a derivative. This is one of the definitions of a derivative. This right over here would be f prime of 2. The derivative at x equals 2 is equal to the limit as x approaches 2 of all of this business. There's other ways to express a derivative as a limit, but this is one of them. And so there you go. From the table, what does the derivative of f of x equals x squared plus 1 at x equal 2 appear to be? Well, the derivative at x equals 2 appears to be equal to 4. And we're done.